Hello students, so today we are going to study about metallurgy. What is metallurgy? Metallurgy is nothing but the science and technology regarding extraction of metals from their ores and their purification for the use is called as metallurgy. Now we need to study what are minerals, what are ores, what are impurities, that is gangue particles. All those things we are going to study in detail in this video. Firstly, what is the definition of metallurgy? Metallurgy is nothing but the science and technology regarding the extraction of metals, now extraction of metals from their ores. We'll study in detail about ores. So science and technology regarding the extraction of metal from their ores. We are going to extract metals from their ores and their purification for the use is called metallurgy. Now we'll study difference between ores, minerals and unwanted particles, that is gangue particles. Now what are ores? What are minerals? Firstly, definition of minerals. What is the difference between minerals? What are ores? What are gangue particles, that is matrix? Definition of minerals. What are minerals? The compounds of metal. Minerals are nothing but the compounds of metal metals that occur in nature along with other impurities. The compound of metals that occur in nature along with other impurities. Are called minerals. So we can say minerals are nothing but compound of metals that occur in nature along with other impurities are called minerals. Then the definition of ores. What are ores? I'll explain you the difference between metals and ores. Ores are nothing but those minerals from which metals can be extracted profitably and economically are called as ores. We can say those minerals from which metals can be extracted profitably and economically are called ores. We learn the difference between minerals and ores. Now I'll give you 4 samples. Sample A, B, C, D. So here are 4 samples. These are samples of minerals. We can see that this red color, it denotes metal or its compound, and the black one, dotted black color, it denotes impurities. What we can see over here, in sample A, we can find more metals or its compound. Red color denotes metal or its compounds. Even in sample B, we can see there are more metal or its compound. But if you look at C and D, you can see there are more impurities and very less metals. See, these impurities are in the form of sand and rocky material as well as soil. So we can see that A and B can give more metal or its compound. So these two are nothing but ores. So what does the definition of ores say? Those minerals from which metals can be extracted profitably and economically. We can see that A and B, we can get more metals, we can get more profit compared to C and D. So we can say A and B both are ores. We can say those minerals from which, these all are minerals, and from those minerals from which metals can be extracted profitably and economically are called ores. Thus we can say all ores are minerals, but all minerals are not ores. Minerals are nothing but compounds of metal that occur in nature along with other impurities are called minerals. But those minerals from which metals can be extracted profitably are called as ores. Here we can see that A and B, they are ores, whereas C and D, we can get metals but we can get very less profit because there are more impurities. So we can get more metals from A and B. These two are nothing but ores. So that's what we can say. All ores are, these two are ore. All ores are minerals, but all minerals are not ores. So this was the definition of ores. So next one, impurities. The impurities are called as gangue particles or gangue. We can also term it as matrix. Impurities in the form of soil, sand and rocky materials. Present in the minerals are called gangue. In simple term we can say gangu, okay, but exactly it is gangue. So what are gangue particles? Impurities in the form of sand, soil and rocky materials present in the minerals are called gangue. So this is what the definition. Now we'll study the basic principles of metallurgy. In metallurgy, when we are extracting metals from ores, we need to remove the impurities. These impurities are nothing but unwanted particles, and these unwanted particles are in the form of sand, soil and rocky material. Then we'll study stages involved in metallurgy. What are the stages involved in, what are the stages, or we can say what are the steps involved in metallurgy? Basically there are 3 steps. Which are the 3 steps? First one is preliminary treatment. This is the first step. second one is reduction, and third one is refining. So what are the stages involved in metallurgy? Preliminary treatment, reduction, refining. Preliminary treatment, reduction and refining. Now what is preliminary treatment? In preliminary treatment, concentration of ores takes place. So preliminary treatment involves concentration of ores. Concentration of ores means removing unwanted particle. Removing unwanted particle in the form of sand and rocky material. If you remove those unwanted particle, ores will be concentrated. Or we can call it as dressing of ore. So there are various methods. So our first step will be preliminary treatment, that is concentration of ore. In concentration of ores, we have to remove the unwanted particles. So we will study in detail about preliminary treatment. There are three steps: preliminary treatment, reduction and refining. We will study in detail about preliminary treatment, that is concentration of ores. Ores can be concentrated by various methods. Basically there are two methods. One is physical method, and the second one is chemical method. In physical method, ores are concentrated. Even in chemical method, ores are concentrated. How? By removing the unwanted particles. But in chemical method, there is a use of chemicals. But in physical method, there is no use of any chemicals. So physical method, there are various methods. First one is washing. Then magnetic separation. We will also study froth flotation process. So washing, what is washing? Preliminary treatment, it is concentration of ore. It involves various methods, physical methods as well as chemical method. Chemical method, we'll discuss physical method. First is washing. What is washing? Washing means ore is powdered and crushed and it is washed with a stream of water. Now ore contains two things. One is heavier particle, that is metal. Heavier particles are metal or its compound, and lighter particles are unwanted particle, that is impurities, called as gangue. Now in washing method, ore is powdered and crushed and it is washed with a stream of water. Ore is powdered and crushed and washed with a stream of water. Ore particles, that is metal particles which are heavier, they get settled down. Gangue particles which are lighter, it get washed along with the water. So in washing method, washing is carried out by various methods. One is Whiffley table method. Method is washing method. In washing method we have discussed, we are going to discuss Whiffley table method. In Whiffley table method, it is a type of washing. Ore is powdered and crushed and washed with a stream of water. In this method of separation, table is made by fixing narrow and thin wooden rifles on inclined surface. What does it mean? This is a straight surface, this is straight, and this is what? Inclined. So these wooden rifles are wooden rifles means small planks of wood. Okay, they are fixed on a inclined surface this way. This is inclined surface. Then the table is kept vibrating continuously, and it is vibrating continuously. Powdered ore is introduced from here and water is also introduced. What happens? Lighter particles, that are gangue particles, they get washed along with the water and they get collected in the downward compartment, whereas ore particles, which are heavier, they settle down between the slits and they get collected in a separate compartment behind that. At the same time, this table is made to vibrate continuously, and since it vibrates, the ore particles are separated. I mean, concentrated metals, they get separated and gangue particles are washed away along with water. So in Wifley table method, we can say the table is kept vibrating continuously. Powdered ore obtained from where we obtain the powder, from mills. Then ore is powdered and crushed and washed with a stream of water. As a result, ore particles, since it is heavier, so it settle down between the slits, and gangue particles, which are lighter, it get washed along with the water. So this is what Wifley table method. Next one is hydraulic separation method. Next one we'll discuss hydraulic separation method. Now what is hydraulic separation method? It is also a physical method which includes washing, I mean use of water. Again, powdered ore is introduced, in which heavier particles settle down and gangue particles, which are lighter, it get washed along with the water. Hydraulics, the next one is hydraulic separation. In hydraulic separation method, there is a tank which is tapering at the lower end. There are one is upper outlet and there is one at the lower side. There is inlet for water. This is water inlet and this is upper water outlet. Now what happens over here? Powdered ore is introduced. It consists of a large tank. Large tank has water. Powdered ore, that is crushed ore, which contains metal compounds as well as gangue particles. It is introduced from here. So this is powdered ore. So when it falls down from the lower inlet, a forceful jet of water is introduced in the tank from the lower side. Forceful jet. Jet means water with a speed. It is introduced from the lower side. Since there is a force in the water, now powdered ore contains gangue particles. So gangue particles, since they are lighter, they remain upside, and metal particles which are heavier, they get settled down from here, and these metal particles can be concentrated ore can be removed from this outlet. Whereas gangue particles, with the help of jet water, gangue particles, they are washed along with the water. So jet water, it carries the gangue particle and gangue particles are removed from this outlet. Basically, once again, what happens over here, there is a tank. It's a type of vessel which is tapering at the lower end. There is a powdered ore is introduced from the upper side. There is a water inlet which has a forceful jet of water with a speed. The gangue particles from the ore, they get washed with the water and they come out from this outlet. Whereas ore particles which are heavier, it gets settled down and it can be collected from this outlet. So this is what hydraulic separation. Next method is magnetic separation. Now what is magnetic separation? Again, magnetic separation is also a physical method in which ores are concentrated. Concentration of ore method is a magnetic separation which is a physical method. In this method, there are two rollers. Out of this, one of the roller is electromagnet. These rollers are attached with a conveyor belt. This conveyor belt is made up of leather. When the belt moves, again this roller will also move. So in magnetic separation there are two rollers. One of them is electromagnet and it is attached with conveyor belt. This is conveyor belt. Powdered ore is introduced through one end. When the roller moves, or we can say when the conveyor belt moves, powdered ore, it comes to this side and it starts falling from here. What happens over here? There are, since one of the, now these ore particles contain magnetic material as well as non-magnetic. We can say magnetic material, say for example iron ore. Non-magnetic is what? Gangue particles. When it falls from here, since one of the roller is a magnet, it will catch the magnetic ore towards itself, toward its side, and it gets collected in a container near the, since the roller is magnet, it will attract the magnetic material, or we can say ore which is magnetic, and it gets collected near a container placed over here. And non-magnetic, that is gangue particles, since it is non-magnetic, it gets collected separately away from the roller in a separate container. This is what gangue, and this is what we can say iron ore. So here we have used this magnetic separation method for magnetic ores, and gangue particles are also separated. At the same time, we can say magnetic and non-magnetic ingredients can also be separated. For example, cassiterite is a tin ore. It contains mainly non-magnetic ingredient, that is tannic oxide. Cassiterite is a tin ore which contains two ingredients. One is magnetic ingredient and one is non-magnetic ingredient. Now magnetic ingredient is ferrous tungstate, this is what? Ferrous tungstate. And magnetic is stannic oxide. Stannic oxide is SnO2. Now first of all, cassiterite, that is a tin ore, it is powdered. Now it contains magnetic and non-magnetic substance, ingredients. Powdered ore is introduced from here and it falls from here. Since one of the roller is magnetic, it will attract the magnetic material, and magnetic is what? See, stannic oxide is non-magnetic and magnetic is what? Ferrous tungstate. So what happens, since ferrous tungstate is magnetic, it will be attracted towards the roller and it gets collected in a container placed near the roller, whereas stannic oxide is non-magnetic, it will be collected away from the roller in a separate container. So we can say magnetic and non-magnetic ingredients can also be separated by using magnetic separation. So this is what we can say dressing of ore, that is concentration of ore. So far we have studied Whiffley table method, hydraulic separation and magnetic separation. So these are the physical method. Now we'll start with froth flotation process. Next method is froth flotation method. Now froth flotation method is based on two opposite properties. Which are the two opposite properties? Hydrophobic and hydrophilic property. Hydrophobic means it has phobia from water, that is moves away from water. Philic means it is attracted towards water. Mostly in froth flotation method, sulfide ores are concentrated by this method. Sulfide ores are concentrated by froth flotation method. Now in this method, what is the process? In froth flotation process, finely powdered ores is introduced in a large tank. This large tank contains ample of water, plenty of water. It contains water. At the same time, vegetable oil is introduced. Vegetable oil, which vegetable oil? The oil can be pine oil or it can be eucalyptus oil. The vegetable oil is introduced. Then in this method, finely ground ore is put into the tank which contains water and certain vegetable oil is used. The oil is what? Either pine oil or eucalyptus oil. Now sulfide ores are concentrated by this method. We have introduced the powdered ore. That powdered ore is sulfide ore. What happens over here? Ores, and it contains ore particle as well as gangue, unwanted particle. Ore particles, since they are hydrophobic, means it moves away from the water, so they are wetted by oil. A tank contains two things, oil and water. Ore particles, what they are? Hydrophobic. Since they are hydrophobic means it moves away from water, so they are wetted by oil. And gangue particles are, impurities, they are hydrophilic. Hydrophilic means they are attracted towards water, so they are wetted by water. After that, with the help of agitator, now I'll give an example. Curd when it is churning action of curd. When you churn the curd, what happens? Butter comes up. Butter is oily. Similarly, that churning action is carried out by this agitator. When agitation is carried out, it rotates. When agitation is carried out, we all are aware the oil particles will come up. So when agitation is carried out, basically what happens? Agitator is used as per the requirement. Bubbles are formed due to blown air. Air is also blown over here. From this side, air is blown. Due to air and due to agitation, what happens? It forms a foam. Due to the churning action, oil forms the foam. And oil, wetted by oil, ore particles are wetted by oil. So it comes up by forming a foam. Now foam is formed due to agitation. This is what the agitator. Agitator, what is the function of agitator? It provides the churning action. Due to churning action, the froth is formed. This foam or froth, which can be collected, it can be removed and it can be collected in a separate container. Now this foam contains ore particles, whereas gangue particles are wetted by water, so they can be removed from the lower outlet. So what is the method in froth flotation method process? We can say froth flotation method, it is working on two opposite properties, that is hydrophobic and hydrophilic property. Mostly sulfide ores are concentrated by froth flotation method. Now this process is carried out in a large tank which has ample of water. Certain vegetable oil is introduced. Which vegetable oil? Either pine oil or eucalyptus oil. Then powdered ore is introduced. Powdered ore, mostly which ore? Sulfide ores. Now sulfide ores, ore particles are wetted by oil. Why? Because they are hydrophobic, and gangue particles are hydrophilic, means they are wetted by water. When agitation is carried out by agitator, and after the agitation there is a churning action. At the same time pressurized air is blown, churning action takes place, and oil forms the froth. Oil, air and water forms the froth or foam, which contains ore particles, which can be separated, which can be removed. At the same time gangue particles are wetted by water, they get settled down and it can be removed from here. So this method is called as froth flotation method. Since the foam floats, we can call it as flotation method. It's a very simple. In your exam you can write on, in this method two opposite properties are used. Which are the two opposite properties? Hydrophobic and hydrophilic property. Mostly sulfide ores are concentrated by this method. This method is carried out in a large tank which contains ample of water, and certain vegetable oil is introduced. Which vegetable oil? Either pine oil or eucalyptus oil. Powdered ore is introduced in the tank, which mainly sulfide ores. Then agitation is carried out. Agitation is nothing but churning action. It is carried out by agitator. At the same time pressurized air is blown. Due to agitation, oil forms the froth. Oil inside the water, it forms froth which has ore particles. It rises above and it forms a foam, and this foam is collected. We can get the get the ores from this foam, whereas gangue particles which are wetted by water, it can be removed from the lower outlet. So this is called as froth flotation method. Okay. Next method is leaching. Leaching is also a physical method. Leaching means getting dissolved. The first step, that is a concentration of ore for metals like gold, silver as well as aluminium is carried out by a method called as leaching. In this, ore dissolves in the solution due to specific chemical reaction. What happens? The ore, it gets dissolved in the solution, whereas gangue particles does not dissolve. Okay, so it can be separated. What happens in leaching? Ores get dissolved and gangue particles do not dissolve. So ores, when it is dissolved, and gangue particles, it is not dissolved, it can be removed easily. So this method is called as leaching. We are going to study in detail about leaching in Bayer's process. So leaching, we can say the first step in the extraction of metals, aluminium, gold as well as silver, is the method of leaching. In leaching, what happens? Ore gets dissolved. So I will stop here and we can continue in the next video. That's all. Thank you.